Hello everyone and welcome back. So in this video, we are going to be taking a look at how to scrape some data from Wikipedia, right? So I have my browser currently open and I'm going to search for lists of largest universities, Wikipedia. So I'll just go with the second result right here, right? And, we are really going to be keeping things simple, right? We can easily scrape this table, and load it into any database of choice, right? For every website, you have an HTML content that is responsible for rendering that website, right? And you find this on all the websites that you go to, basically. So websites can be built with different tools, basically HTML, CSS, and JavaScript, right? But there are some other tools based on the language or ecosystem, right? So for instance, you have React, right, which is a JavaScript library for building dynamic front-end applications. You have Angular, you have Vue, and a whole other, couple of tools out there, right? But at the end of the day, they all compile down to HTML, CSS, and JavaScript, right? So the idea is that for any website you want to scrape, there's an underlying structure which is, given by the HTML, right? So for instance, if we want to view the structure, the HTML structure for this page, I can click on the three dots button right here, then over on more tools, then click on developer tools, right? So you can see that to bring that up using the keyboard, we just use Ctrl+Shift+I, right? So if I just click on that developer tools, let's try that again. All right, so now this is what the developer tools look like, right? So yours might come from the left or from the right, but basically you have something like this where you have these headings, elements, console, sources, network, and so on, right? And all browsers actually have the developer tools. So if you are using Firefox, for example, or you are using Microsoft Edge, you would definitely be able to bring up your developer tools, probably by looking through the settings, right, somewhere around here, or using the Ctrl+Shift+I, right? So you can toggle it on and off, just as I'm doing now, by holding on to Ctrl+Shift, then pressing the I button, right? So that's how you bring up the developer tools. So I'm really interested in scraping this data from this table right here. So what I want to do is, if you click on elements, right, you actually see the HTML structure for the whole web page, right? You can see here we have a div. So these are examples of tags. You have a head tag, right, which is just containing metadata about the website. Then you have a body tag, which actually displays the contents of the website. That's the content you can actually see on a particular website or web page, right? Then you have some anchor tags, which basically is responsible for holding links, right? And every anchor tag will have href attributes, right? So these are basically attributes of the tag. Then the data you get to see on the web page is just displayed in the between the opening and closing tag for that particular tag, right? So you have div elements, right? You have scripts basically for keeping your any JavaScript file that you have. So you can see this is basically JavaScript code, right? So the script tag can point to a file, or you can just put your JavaScript between the opening and closing tag for that particular script tag, right? So, basically that's what the HTML representation of this page looks like, right? But like I said, we're really interested in locating this table, right? So in order to locate any part of the web page easily and see the HTML contents, right, what you want to do is click on the first icon right here, of which when you hover, you see select an element in the page to inspect it, right? And there's also a command for that, which is Ctrl+Shift+C. But I'm going to click on that icon. And when I go back to the web page, any element I point to, right, I'll actually get to see the HTML for that particular element. So it's basically going to jump to the HTML responsible for that element, right? And if I hover on any tag right here, it shows, you can see it's, so basically it shows that element as well on the website, right? So it's more like a two-way thing. If you click on the tag or over on the tag, it shows where the element is, right? And if you just over on any part of the web page, it shows you the corresponding tag for that web page, right? So since I'm interested in this part, let me see. So if I click on this country, it actually shows me the tag responsible for rendering that, that country text or column, right? Which is this, right? So now that I've been able to identify the tag responsible for rendering country, you see just above that, we can see the table, right? That's the table tag responsible for rendering that whole table, right? So within the table, we have like a structure within the table, which includes the head and the body for that table alone, right? Then so for the head, for example, you have a row, right, which just displays like all the columns basically. So if I over on this first TR, you can see it's just giving us a color for that entire row that has all the column names, right? So if I over on the body, you see that, it actually colors the whole body for the table, right? But as far as scraping the data within Python, I first need to be able to download the HTML content, right? Which we are going to do using the request library, right? So once we download the HTML content, we want to be able to filter or select specific tags, right? And that's where Beautiful Soup comes in, right? So Beautiful Soup allows us to, just navigate the HTML structure, or what is referred to as the DOM structure, which stands for Documents Object Model, right? So Beautiful Soup allows us to traverse the DOM structure easily, so we can select elements that we're interested in and, basically perform some operations and some extractions from those elements, right? So we are going to get started with that right away, right? So we've been able to see how to identify any part of a page, or, how to select any part of a page that we need, right? So what I'm going to do now is just search for git bash, then cd into my D drive, diary folder, then projects folder, right? All right, so I'm going to create a folder and call that Wikipedia scraping projects. If I want to open that folder using VS Code, right, making that folder my project workspace, I just need to type code, then Wikipedia scraping projects, right? So VS Code will open that folder as my project workspace. So I'll click on enter. VS Code actually opens that folder as my workspace. So I'll just increase that. And you can see I'm within the Wikipedia scraping projects directory. So I can bring up my terminal using Control J. So now you can see the full part of the current directory or the current folder, right? So I'm within the Wikipedia scraping projects, and typing pwd will also confirm that, right? That's present working directory. All right, so I'll move this down a bit. So the first thing I'd like to do now is to create my Python virtual environment. So I'll type python-m-venv. Then I would like to name the virtual environment venv as well. While we wait for this command to release the terminal, I'll just create a file and call that extract.ipynb. Right, so I'm able to open a Jupyter Notebook file because I have an extension within VS Code that allows me to do that, right? So VS Code is a very powerful development environment because you can basically, install any extension that allows you to do what you need to do for any external or for any feature that doesn't come pre-installed with VS Code, right? So for instance, the way I'm able to open a Jupyter Notebook file within VS Code is I installed this extension. So it's a very popular extension. If I just search for Jupyter, so you can see this Jupyter extension by Microsoft, right? That's the extension you want to install. So it's an extension pack that comes with other extensions. You can see this one says Jupyter Cell Tags, Jupyter Slideshow, and all that, right? So it basically allows you to run Jupyter Notebook files from within VS Code, which is really good, right? So you can just install this, then you'll be able to work with Jupyter Notebook files within your VS Code environment, right? But the thing is, if I try to run any code, So let's print hello. Then it's going to ask for a Python environment to use, right? For the Jupyter Notebook file. So I'm going to select the virtual environments I created. Then it's actually the recommended environment. So I would just click on that. Then you see here it says connecting to kernel. That's the VMV created here, right? So it will ask to install the IPython kernel package, right? So just click on install and we'll give that some time to actually install, right? In order for us to scrape the data we need to install requests and the beautiful soup library, right? So what I'm going to do is, before I install any package, I want to make sure that my batch environment is activated, right? So I'm going to run source venv scripts, then activate, right? So that will activate my virtual environment, and I can see that I'm actually using the virtual environments currently. If you're on a Mac or Linux, the scripts here would be bin instead, as in bin, right? So just type source venv bin, then activate. All right, so now that our virtual environment is activated, I want to install the request library, right? Then the BS4 library, which is for beautiful soup. Right, so I'm going to click on enter. So now it's using the cached version, which I already have installed within my system, but just give this some time. And if you don't have these two libraries, they will be installed for you. Request and beautiful soup 4 have both been installed in my virtual environment, right? So if I expand that, if I expand the lib folder, then we can see BS right here, right? And these other packages are dependencies for BS4, right? All right, so then the other packages, of course, are packages required by the IPython kernel, right? So those are actually still installing. And as you can see, we have some changes going on right here. Right, so what's left now is just for us to wait for the IPython kernel to finish installing all the required packages. So as soon as that is done, we'll continue to see how we can scrape the data from Wikipedia. All right, so now the installation is done and we can see hello printed right here, right? So let's just print something else, right? So we see hello printed right here. So we can actually start working on scraping the data from Wikipedia now. So the first thing I'll do is to import request, the request library. Then let's also import the beautiful soup class. So that's going to be from BS4. Import beautiful soup, right? So I'll run that cell. So I'll hide my terminal for now. So now we're going to pull the HTML content from Wikipedia, right? And I'll just create a variable and call that response. That's going to be request.get, right? So I'm trying to fetch some data and I need a URL, right? So let's go back to Wikipedia and just copy this URL, right? So I'll paste the URL right there. And that's basically everything I need to do. Basically all the information about this web page, right? Including the metadata and some other information. So I'll run that. And that was successful. So let's see what response looks like. And it's basically a response object. This is a status 200, which indicates that we're able to fetch the data successfully, right? So you have other status codes like 4144, 500 and all that. But this is a good indication for us, right? So what I really need is the contents, right? So if I type response.contents, you can see I have a byte string, which actually shows the HTML, right? So you can see it starts with doctype HTML right here. And we have printed on a single line, basically. This is where beautiful soup now comes in, right? So I'll just type soup equal to beautiful soup, then pass in the response dot contents. Right? Because the response dot contents has the HTML, right? But beautiful soup now allows us to work with the HTML, to do some extraction, some filtering, and all that. Right. So I'm going to run that. And that was successful. Right. So now that we have a soup object, okay. So it's just soup, right? So by just typing soup, we can see the HTML content, and the output was actually truncated, right? So it's actually going to be very long, right? So we have like all the HTML content for this page, right? And so what we need to do now is to be able to locate the table we're interested in. And, this is something very important because we have to look for a way to uniquely identify what we need on the web page, right? Because a web page can contain multiple tables, right? And if all the tables have the same class, then it might not be so easy to find the particular table we're looking for, right? Because when working with HTML, a class can be assigned to multiple elements, right? So that's why it's called a class, because basically multiple items can belong to that class, right? So class might not really be a good way to uniquely identify a tag, right? But if a tag has an ID, then the ID in a particular HTML document is always unique, right? So if you're identifying an element with its ID, then you can be sure that that element is going to be unique, and it's always going to be, the elements you want to extract data from rather, or it's always basically going to be the elements you are searching for. But when you are relying on a class, then you might have multiple, items having that same class. So you just want to be careful of that, right? But in this case, I believe this is the only table that has this class. So it's safe for us to use this, the element's name and its class attributes as a unique identifier for that element. Right, so now let's just continue with what we're trying to do. So I'm going to search for, and to search for elements, right, all you need to do is use soup.find. Right, so you have find all and find, right? So what find all would do is to find all the elements that have the attributes you are specifying, right? So for instance, if I type find all, and I'm trying to find all table elements, then enter, you see that it actually returns a list, right? It returns a list of all the tables, on that web page, right? So, but to narrow things down a bit, I'm just going to use find, right? After specifying the elements I'm trying to look for, I can also specify some attributes, right? And like I said before, once you have an element, whatever is within that element, right? Within the opening tag of the element represents the attributes. So for instance, this div element has a class attributes, and these are the values of the class attributes. So if you are specifying multiple classes, right, you just separate the classes by space, right? So basically, MW content LTR is one class, and MW path outputs is another class, right? So two classes have been given, to that particular attribute, or to this class attribute. Then lang is another attribute for this tag, followed by dir, right? But in this case, from the table so let's just look for that table again. So for this particular table, I can specify the sortable class, right? So let's try that. Let's try using the sortable class and see if we're able to get the table we need. So I'll go back to the code, and for attributes, that's going to be the class attributes, right? Then I'm looking for any table elements with class attributes of sortable, right? So I'll type sortable here, then enter, right? And we can see that we have these table elements with class sortable and wiki table, right? Which we have. So you see that even though I didn't specify the wiki table class, it actually detected these table elements with class sortable and wiki table as well, right? And you can see the next tag below the table tag is the C body, right? And if you look at, so it's omitted the head, and we have C body right here, right? Things are rendered a bit differently, but we can see from the T body here, we have a table row, right, which is the first row. And that first row basically represents the column, right? Within the first row, we have a couple of table head tags, right? So the first one is country with its opening tag right here. So this is the opening tag, and this is the closing tag. for the table head, right? So we have country, then we have another table head, which is university, right? So we're actually looking at this element right here. So we have a country, we have university, then we have founded, type, enrollment, which we can see here, founded, type, and enrollment. Then we have ref as well, right? But we won't be scraping the ref column, right? But you can see everything is within a row. So we can see we have opening tag for a row here, and you'll find the closing tag to be just after all the table head, elements, right? So that represents one row, and that first row is just a row containing the column names, right? And you see that the next row here actually now contains some data. So you see that we don't have th anymore after the tr elements. We now have td, which stands for table data, right? So that's how you know that everything you are extracting here represents the column header, and everything you are extracting in subsequent rows would represent the data for that given row, right? So for this row, the first cell in that row, which is this td element, should actually be for the country, right? So if we scroll a bit, you can see this is actually a very long tag. But if I scroll to the left, or to the right rather, we can see the actual country name is Bangladesh, right? This is the country name. So this is what we're actually interested in extracting, right? So that's for the first cell. And the second cell, still within the first row after the header row, right? The next cell just contains, let's see, the name of the university, right? So this is the name of the university, and you see that the second position for the header row is for university, right? Then for the next header cell, we have founded. And if we look at the third table data elements in the first row, we have 1992, right? So that's how things have actually been structured in this HTML table, right? So this actually allows us to know how to extract what we need, and align it with the column header, basically, right? So this will actually make more sense as we proceed with this project. You see here, I'm just using find, right? So what find will do is it will give you the first element that matches the criteria you've specified, right? So the first element that matches this criteria actually turns out to be the table we're interested in this case. But that might not always be the case if you have, multiple elements having the same criteria, right? So to find all the elements that matches a particular criteria you specify, you can use the find all method, right? So you can either use the camel case style here, or you could use the snake case that's using underscore, right? The line of code will actually work both ways, right? So if I use find all, you see that the result is actually going to be an array or a list, right? So you actually get a list of all elements that matches the criteria. And note that this table element is actually a parent element to all these other elements within it, right? So let's use find again, which returns the first element that matches. And let me see if I can use prettify here. All right, it doesn't actually return it in the expected way, right? But basically, this table element here is actually a parent element to all the other elements, as you will see. So if I bring this up a bit, right, you can see this is the table elements here, and it's a parent to T head and T body, right? And T body is a parent to all the TR elements, right? So that's basically how it is, right? So here we're just printing out that table elements and all its children, basically. So we've been able to identify the table elements, and that is going to be a beautiful soup elements object. So let me just type table here. We want to be able to find all the rows, right? So I think an easy way to go about this would be to find all the TR tags within that table element, right? So we've already saved the table elements in this variable. Now I can add find all. So now I'm trying to find all the table row tags or the table row elements. right? So this will return a list, right? Because it's find all. And if I enter, you see that this is actually an array of all the TR elements. And don't forget, the TR elements also act as parents to some other elements, right? So if I go back to the web page, let's open Cbody, then TR here, or even Thead and TR, right? So you can see the Thead has just one row, right? That row, which is TR, has some children. About these are 1, 2, 3, 4, 5, 6. So it has 6 children, right? And that's basically just the same thing we have right here. So this TR is the parent element, and all the CH before the closing tag of TR serve as the children for that TR element, right? Then you see after the comma, we have the next item in the list, which is another TR, right? And this TR this time now has CD elements as children, right? To extract the first item as the header row, right? Let's name this variable TRs. If I type TRs of 0, right, which is, basically this row, we can use another find all, and this time we're interested in CH. So you see that this now gives this row as an array of all the TH elements, right? I can decide to write a for loop, right? So in fact, let's just do that. I can say for item in everything here. Since I know TRs 0 does find all TH will give me a list of all the TH, right? I can say print item dot text, right? So this method or this property right here, this dot text property, will only now give me the text within the TH tag, right? Or it doesn't have to be TH tag, it can be any tag, right? But once you are looking over HTML tags and use dot text, then you are going to get the text between the opening and closing tag for that, for that particular tag, basically. So if I run this, you see that we have just the text, right? Which includes country, university, founded, type, enrollment, and ref, right? And if I want to remove extra spaces and all that, I can just use strip. And, that doesn't include any extra spaces, right? So these are all the elements from the first row.